So this is the integration by parts. We are going to introduce that. It comes from the products rule. Let's review the products rule a little bit here. So if you find the derivative of the product of two functions, say u and v, the derivative is u prime v plus u v prime. Now, when you integrate both sides with respect to x, the left side will be uv, you get this back, right? And antiderivative of the derivative, you get this back. The right hand side, you will have two parts. One is this, the other one is this. Okay, and then now if you let's leave this here. So this part uv prime dx is going to be equal to uv minus antiderivative of u prime v dx. This v prime dx is the same as the dv, the derivative of v. And this u prime dx is the same as du. Okay, so therefore this is actually the result that we are going to use. Okay, so this result is called the integration by parts. Now let's work on one example. So the example is this: x sine x dx. So you need to somehow come up with what u is and what dv is. You need to make the assignments here. And so in the class, we mentioned a few, like one is the so-called liate, L-I-A-T-E, which is something I don't really recommend. I'm going to write this down, L-I-A-T-E. What that means is you want to call your u in this order. It's recommended to follow this order. If you see a log function, this I means inverse trig, A means algebraic, T means trig function, E means exponential. So you want to set your u in the order showing here. So if we use that rule here, the x is so-called the algebraic function, sine is the trig function. In this case, because a occurs before the t, you want to call the u as x. And once you call the u as x, what's left should be your dv. So I'm going to say dv is sine x dx. According to this formula, you need to figure out the v, which means you need to find the antiderivative of this expression. You also need to need the du, so you need to find the derivative of the u. Let's do that. So du is equal to, so find the derivative of x, which is just 1, so it's 1 dx, which is dx. Now find the v. dv is sine x, therefore the antiderivative of sine x is negative cosine x. Let's apply the formula now. So therefore original integral is equal to u times v, and if you look at here, which this is u, this is v, so you multiply these two together, so it's equal to negative x times cosine x. The formula says minus the integral of v du, so minus integral of your v is this guy, du is this guy, so you multiply these two together, so times v is negative cosine x, du is just dx, which is equal to negative x cosine x. Now this negative sign and negative sign cancel out, you get positive. And then find the antiderivative of cosine x, which is sine x. At the end, do not forget about c. This is what it is, how we solve this problem. A few comments to make. First of all, after you do when you choose the u, you please note that du should not be too difficult to find, so that's good. Here u is x, du is easy to find. When you assign the dv, make sure that this is easy to find the antiderivative. So sin x, it's easy to find its antiderivative. Next, after you apply the formula, you want to check this result. Make sure that this result compared to your original one, it's simpler, which is the case here. So therefore, this is we are on the right track. Now, I would suggest you to try the same problem, but choosing u as sin x, dv as x dx, and then carry out, apply the formula to see what you have. Okay, and then with this experience in the future, it will help you choose the u and dv wiser. So that's it.